We're at sort of a transition point in the project. We have all of our mechanical systems on the inside of the building. The electrical, plumbing, heating systems have all been installed, so we're just about ready for drywall. So we thought it'd be a good idea to open the house up to the public and show people how various things work. Ask questions and get comments from other building industry professionals. So today we ran a blower door test on the building.
Blower door test tests the leakage of the house. We depressurize the house.
Put a piece of plastic over the door and put a fan in that, and then that fan actually depressurizes the house by blowing air out. And so by checking the indoor pressure versus the outdoor pressure, and that tells you how leaky the house is, how much air is coming through all the little cracks in the building, around the doors, around the windows, around the wiring, around the plumbing. So that's why you do a blower door test at this stage of the construction, so you can fix those and find those holes so you can really tighten the building up.
We compare it to other houses and to other codes or requirements for different programs. And this house is coming in 1.35 ACH 50, and a code house has to meet 5 or under. So this is well under.
One of the systems that we are putting in place is an energy monitoring system. There's cabling throughout the building. We'll actually monitor the temperature of each room, and also the sensors on some of the mechanical equipment. And so over the next course of the year, we'll actually have to be data logging how the building is performing. And so Ecotope has volunteered to manage that data logging process for us. And so that'll be a really good benchmarking to see how this type of home performs in the long run. Positive Energy came in, our electrical contractor, and put all the boxes in, brought in all the services, and wired the building. The panels do have chases drilled into them during the manufacturing process, so once you get in there, you can feed wires through. The project is targeting the EPA, the Environmental Protection Agency's WaterSense program, which is a very low usage water program. So we have a central plumbing core. The building was designed so that the water heater and all the water use points are very close to that. So you don't have to wait a long time for the hot water to get to your place that you need it. So the red pipes are the hot water pipes. And it's all PEX, so it should be fairly easy on people to use. We actually are connected to the sewer system now. The existing building that was here years ago was connected to the sewer, so all we had to do was reconnect to that existing line. So that made that little step relatively easy. Okay. We're working on the siding. The siding has a couple different factors going on it. We have the exterior pre-painted Hardie siding. And then behind that is actually a rain screen system. So the siding is not attached directly to the building. It's actually built out from the building so that there's airflow behind the siding, so moisture doesn't get driven into the building and into the wall systems. That's right. Recently I've done some groundwork around here, doing some backfilling and some grading. Very soon after you do the grading, you need to recover the soil with straw or some type of erosion control measure to keep the dirt and silt from leaching off onto the neighboring properties and into the rain system or into the creeks. One of the jobs of the building inspector is to make sure that our erosion control BMPs, best management practices, are in place and are operational.